What's going on, guys? Welcome back to my channel. In today's video we'll be talking about simple harmonic motion. There's two different variations for SHM or simple harmonic motion. It's simple harmonic motion and time, and the other one is simple harmonic motion and displacement. So we'll start with the time one today. Before we look into any of the examples, let's just try and understand the theory. I'm sure you can get it in the textbooks, but we'll try and go through it today over here. So, very general sort of equation we've been given for simple harmonic motion is x equals to a cos n of t plus alpha plus c. So, a in this case determines the amplitude of the graph. Obviously, you've got cos. We've got n over here. This determines the frequency, how frequent it is, and obviously you've got alpha, or the angle which shifts the graph left and right. And then c plus c, this is the center line, or the center in a way. This shifts the graph up and down. Let's worry about these equations over here. So the first step I will do is take the first derivative of this in order to try and understand these equations over here. So x dot would then be negative n. We take the n out in front. We go first, because first derivative of cos is negative sine. A sine n of t plus alpha. Correct? Next step, take the second derivative. Again, we get negative n squared a cos of n of t plus alpha, but we know what cos of n of t plus alpha is x in this case, so x dot then equals to negative n squared x. So this is where this equation comes from. Worrying about this over here, if we come back to this part, the top one, let's denote that as v equals to negative n a sine n of t. Correct? Square both sides, so we get v squared equals to negative n squared, but negative goes, it's just n squared in this case, n squared a squared sine squared n t. Next step, sine squared n t would be 1 minus cos squared n t. So v squared equals to n squared a squared 1 minus cos squared n of t. Cos squared n of t, come back to this, we then get v squared equals to n squared a squared 1 minus x squared upon a squared. Correct? Next step, v squared equals to n squared in this case. A squared minus x squared all upon a squared gone, which then gives me a squared minus x squared. So this is what this gives me over here, which is relevant to this equation over here. So this is the this is the period of a graph. In a way, if we draw a cos graph over here, the period is between this area, this and this right here. It determines, and then the frequency is just 1 upon t, as we mentioned over here. So just a little basic understanding of the formulas. Now let's go on to the first example. Looking at this first example, we've written down all the important equations we're going to use in order to help this question. The motion of the particle is given by the acceleration, which is negative 16x, x equals to 0 and v equals to 4 when t equals to 0. Find x in terms of t, stating amplitude and the period. So, first thing I will do, this over here, second derivative, negative, not negative, we have x double dot equals to negative 16 x n squared, so n therefore equals to 4 because 4 squared is 16x. So if n equals to 4, coming back to this equation over here, x equals to a cos 4t plus alpha, equation number 1, and x double dot, single dot, the first derivative, which is velocity, negative 4a sine of 4t plus alpha. This can be equation number 2. When t equals to 0, x equals to 0, so come back to the first equation, 0 equals to a cos alpha, correct? Divided by a, 0 equals to cos alpha. In this case, alpha equals to pi upon 2. Because when is cos 0? At 90 degrees. So it starts there, comes back up. Alpha has been given. Come back to the velocity part to find a. When t equals to 0, v equals to 4. 4 equals to negative 4a sine of 90 pi upon 2. We figured out what alpha is. Sine 90 just gives me 1. 4 upon negative 4 is negative 1 equals to a. Amplitude equals to negative 1. So we can rewrite this in terms of our first equation number 1. Therefore, x equals to minus cos 4t plus pi upon 2. Correct? But negative cos of alpha or negative cos of theta is also cos pi minus theta. So write it as its positive case. You can go cos pi minus 4t minus pi upon 2. Correct? We have cos pi minus pi upon 2 is just pi upon 2 minus 4t. So that is x in terms of t in this case. Amplitude in this case would be 1. So a equals to 1 and t, come back to this equation over here, 2 pi upon n, 2 pi upon 4, t equals to pi upon 2 upon 2. So that is how you do this first example. Relatively straightforward. I recommend in an exam, if you ever come across any of the simple harmonic motions questions, write down these equations. Save so much time and so much of your energy when you're solving questions in the exam. So yeah, that is example 1. Now go on to the next example.